Everyone.
It's Mrs. Flynn.
And Mr. Rops. We are here to talk about the next derivative rule. We did the power rule. The next one is the product rule. And so if we're given a function where y is equal to f times g, then the derivative is going to be
F of x.
Right. Take the first function
Times the derivative of the second, g prime of x,
plus
the second times the derivative of the first.
Right. So the product becomes a big thing. You get the derivative times the function time plus the derivative times the function.
Now in your IB, it states it as y equals u times v, which is just the same thing here, the function times another function. And it says that your derivative is dy dx equals u, the first, times the derivative of the second, which is dv dx, plus v times the derivative of the first, du dx. Just keep that in mind because as we're going along and we start to use different forms, this is the one that will be in your IB formula pack.
I try to avoid that one because my u's and v's look the same.
Yeah, and
so,
it's a long thing to write out, and I usually write out something else. I guess I usually just write out u times v prime plus v times u prime. So you'll probably see me using that one a lot.
Right. And you'll know if it's Miss Flynn because you can tell the difference between her u's and v's, and you can't tell the difference between mine.
All right. Here we go. Let's go ahead and try this.
All right, here we go. So we have h of x. We need to find the derivative.
So let's do h prime of x. So using our
rule, we write down the first function, which is x squared plus 1.
Times the derivative of the second.
Right.
Which is 2 times 3x plus 1. Plus the second 3x squared plus x times the derivative of the first, 2x. Now we just have to clean it up. Just algebra. So this is the same thing as 6x here. So we have 6x to the third.
Right.
Plus x squared. Plus 6x. And plus 1.
Plus 6x squared.
6x to the third.
Oh, thank you. Plus a 2x squared.
Okay, once again, let's combine some like terms. Now we have 12x cubed, 3x squared, 6x, and 1.
Plus 1. Super. So, just to recap, we wrote down the first function, took the derivative of the second function, plus wrote down the second function, derivative of the first function.
All right. For part B, they want us to expand h of x. So before we even find the derivative, we should expand it. So this becomes 3x to the fourth.
X
plus
cubed.
X to the third.
Plus 3x squared. Plus x. And now we
can't simplify that anymore. So
now we take the derivative.
Now this one, we're not going to use the product rule, obviously. We're just going to use our power rule.
Okay, so
4 times 3x to the third. 3 times x squared. Bring our 2 out in front. 3x plus 1.
Which simplifies to 12x cubed plus 3x squared plus 6x plus 1.
So what do we notice about these?
Well, conveniently they are the same.
Does this surprise you?
No, it shouldn't because you're taking the derivative. So no matter which technique you use, if you use them correctly, you should get the same derivative.
Math makes sense.
Math makes sense. It all works out nice. Okay, let's try another problem. Okay, so now we're given f of x equals 3 minus 1 over x times x plus 5. We have to find the equation of the tangent line at x equal to 1.
Ooh, equation of the tangent line. Well, to find a line, we need two things. We need a slope and we need a point.
Right.
Well, we have x to be 1 here, we can quickly find our other point.
Right, the y-coordinate of that point.
So that y-coordinate, if we plug it in, 3 minus 1 is...
So 3 minus 1 is 2.
Times
1 plus 5 is 6.
So there's our point.
1.
Now all we need to do is find the slope. Well, we can find the slope at this point by finding the
derivative.
Yay.
Yay.
So let's find dy dx. And again, since we have two numbers multiplied by each other, we'll use the power rule. So our power rule states...
Or product rule, you mean?
Yeah, that's what I meant. Yeah, thanks.
That's okay.
First times the derivative of the second plus second times derivative of the first.
So just 3 minus 1 over x?
Derivative of x plus 5 is just
1 plus x plus 5, and the derivative of the second. Derivative of 3 is nothing.
Now we have negative x to the negative 1.
So we pull down the negative 1.
That becomes positive.
Right.
X, subtract 1.
Negative 2.
Negative 2. Okay, to simplify this a little bit, 3 minus 1 over x plus... This is 1 over x squared. So
Right.
we'd have x over x squared plus 5 over
X squared.
This is the same thing as,
1 over x.
and if we have a minus 1 over x plus 1 over x,
They happily cancel
they
away.
are gone. So we are left with just 3 plus 5 over x squared.
Okay. So now that is a function for the derivative. We need to find the equation of the tangent line at x equal to 1.
So if we want to find the slope of the tangent,
Right.
we can just take this equation and plug in, since we know we're doing it at 1.
Right, so we find the derivative at 1.
So it's 3 plus 5 over 1 squared.
Which is then going to be 8.
8. So now to find the equation, we can think about y equals mx plus b. Or did you want to use
Boo,
one
boo,
slope?
hiss, boo, hiss.
Okay.
So y minus 12, y minus y1. Do you do that?
You want to do that one?
with
Okay,
your kids?
yeah.
I love this equation.
Okay.
It works out so nice and
They
easy.
both work.
But this is just one-stop shopping.
Okay. Y minus 12?
8.
X minus 1.
This one is 1. And so if you simplify that, minus 12, you get 8x minus 8.
So
And you want to
add 12 over here. We have y equals 8x
plus
plus
4.
4.
Okay, there's our tangent line. It's a lot of
There's
work
eight.
to get the tangent.
It is, but now we have to find the normal.
Normal. Right, so the normal is perpendicular to the tangent line. And so we need to take our slope.
Slope of the normal. If we already know that our slope of the tangent is 8, then we know the slope of the normal is negative 1 over 8. Just so I don't make Mr. Rumps mad, y minus 12 equals negative 1, 8.
X minus 1.
1.
And then we multiply both sides of the equation by 8.
So now we have 8y minus
96.
9 equals.
Negative x plus 1. Oh, no, the 8s are gone.
Yeah.
Negative x plus 1.
Plus 1?
Right, and if we... What form do you want to put it in?
I
Y
didn't
equals
think about
mx
that.
plus b?
No, that'd be too much work. Let's just put it in standard form.
Okay, great.
8y, bring this x over, plus x equals, bring that over,
97. Super.